So we're going to look at pedigrees and how traits can be traced through families depending on the records that we have. Now, normally, remember I told you you would be using these two questions as a guide to help you set up your keys. But since this is our first time, I'm starting out working these out for you. So this problem says below is an autosomal dominant pedigree tracing the passing of Huntington's disease. And I've set up the key. So I've already told you it's autosomal dominant. So right away, you would go here and you'd see that means that the ones that are shaded in would have the capital letter. Now, because for the dominant trait, you only need one allele, we don't know if it's big H or big H little h. And so we're going to have to try to see if we can figure that out by working backwards. That means that the lowercase letter, two H's, are going to be the not shaded in ones. So I've done like I've done before for you and made these little click and drag things. So I always start with whatever is labeled with the two recessive alleles. So in this case, it's going to be my not shaded in ones. So right now, if you're following along with me and you haven't done this yet, hit pause and see if you can go ahead and click and drag these to each one of these problems. Okay, so hopefully you've had a chance to click and drag the two little H's to every single shape that does not have it shaded in. And so this autosomal means that it's not sex-linked. So that means we can treat men and women, or the circles and squares, the same. Now, we've got to work backwards. If number 13 has two little h's, we know she had to have gotten one from her dad and one from her mom. Well, we know her mom has one big H because it's shaded in. And now we know that the other letter has to be big H, little h. And so we can work backwards like that. We can either look at parents or we can look at children. So for example, if we look at generation 1, person 2, that person, this mother only has a little h to give. That means all of her children should have at least one little h. So that means that this child right here had to have one little h from her mom. But if you notice, she's shaded in, so that means she has to be big H, little h. Now, unfortunately, we'll never be able to say big H unless we actually have some type of genetic testing. So if we can't figure it out, which is possible but rare, you can use the big H/, which means that we don't have enough information to figure this out. So I'm going to get you to pause and see if you can determine for all the shaded in ones, is it big H, don't have enough information, or big H, little h based on the parents or the children? Hit play when you're ready to check your answers. If you're ready to check your answers, we're going to start up here at the top. We know that he's got to be one of these two, big H, not enough information, or big H, little h. If we look at his children, this son right here is little h, little h. So we know he had to have gotten one from each parent. So we know that this dad has to be big H, little h. If we look in second generation, number 5, we can either look at his mom or we can look at his daughter. Either one. They have two little h's, which means that he has to have at least one little h. Because the square is shaded in, we know he's big H, little h. Now, because of his wife, we know that this individual down here has to be big H, little h. And finally, this last one, third generation, person number 9. If you notice, her father has two little h's, so that's the only thing he can give her. So she has to be big H, little h. Notice in this situation, we were able to figure out the genotype of all of the individuals without using the unknown or there's not enough information. Again, looking at what we're actually looking at here, we're saying that the shaded in shapes are autosomal dominant. So that means that all of these are going to have a capital letter, and autosomal means that it's not going to be linked to the X. It's going to be on chromosomes 1 through 22.